Hello everyone. Today we'll be talking about how do we obtain information from the graph of a function. And this is not only important in real life because a lot of, I guess a lot of business applications, a lot of scientific applications, data can be modeled by all kinds of different functions. And it's kind of nice to be able to look at the graph and interpolate or extrapolate, future values or past values of a function to help us predict what will happen in the future or won't or will happen in the past. Anyway, so not only that, but also this is very important for calculus. Right now you're in pre-calculus, but next semester this will really be helpful because there's a lot of looking at graphs and obtaining information from them. And again, I think if students haven't gone over this concept in pre-calculus, they have a hard time in calculus. So it's very important for both of those reasons. But a lot of this stuff is review, which is nice, but so we got a nice looking graph here. It's got a lot of straight portions, it's got a lot of curvy portions, it's got an arrow going up forever this way, it's got an arrow going to the right forever this way. Lots of highs, lots of lows, very interesting. Let's see, let's start with this first question here, see if we can't answer this. First thing they want to know, is this the graph of a function? Let's see, I remember that we're supposed to use the vertical line test. Line test, okay, which should be familiar. We kind of reviewed it in this class, but is also, I believe you learn it in Math 89 or Math 90. The vertical line test states that a graph you're looking at is a function if any possible vertical line only intersects the graph at most once. So in other words, if you can find a vertical line that intersects this graph more than once, it's not a function. But anytime I think of a vertical line crossing this graph, I believe it would only cross it one time. So I think the answer to this question would be yes. Because again, I cannot think of a vertical line that would intersect this graph more than once. Alright, we're doing good here. We got one down. Next, let's see. Now we're talking about domain. So okay, if you recall, domain and range, they're closely related. They're almost the same question, except one asks about x values and one asks about y values. So domain is asking you basically what kind of x values does this graph take on. So in a way that we would describe it to someone would be to tell them how far to the left this graph goes, and then we'll tell them how far to the right this graph goes. So looking at this graph, it looks like on the left side, they're indicating with this arrow that it's going to be going upward and to the left forever. So I'll indicate that with a negative infinity. It's going off to the left forever, which is the negative direction. And then if I look over to the right, it looks like over here as well it's going to the right forever. So I guess the domain would be negative infinity to infinity because the graph goes to the left forever, it goes to the right forever, and also it takes on every x value in between. There's no x value I can think of that it isn't covered by some point on this graph. Okay, so that's pretty typical, I believe, for a lot of functions we look at, that the domain is negative infinity to infinity or all real numbers. Let's see, now the range is very similar except we're telling them what kind of y values this graph can take on. So in this way, instead of saying how far to the left does the graph go and how far to the right, we're going to say how far down and then how far up does the graph go. So let's see, looking at this thing, I believe that the lowest it goes would be at this area here. This is the lowest point, I believe. And it's kind of hard to line it up exactly with the y-axis, but I think what they're trying to show us here is that it's lining up at -3 on the y-axis. So -3 is the lowest this graph goes. And another thing is that, remember that you use brackets on -3 if there's actually a point at -3. And there definitely is a point there. They have it kind of shaded really darkly, so you could definitely see it. And let's see, how high does this graph go? This point actually appears a little bit misleading. It looks like that might be the highest point, but if you recall, we were looking over here on the left side, and actually that arrow is indicating that it's going up forever. So I'd actually say that this goes from -3 to infinity, because it only goes down as low as -3, but there's no upper limit to it. It's going up forever. Alright, well, I think we're doing good here. What else do we have? X-Intercepts. So the good thing about X and Y-intercepts is that the name is sort of self-explanatory. The X-Intercepts are all the X values at which this graph intersects the X-axis. So let's see, looking at this graph, Looks like there are 3 x-intercepts. There's one kind of over here on the left side, and it looks like that guy is, I would say, negative, just say negative 5.5. I mean, I'm thinking that's what it is. Let's see. X equals negative 5.5. Don't worry too much about getting that value exactly right. Like if you say, well, actually that looks a little bit more like negative 5.6 or negative 5.7. You know, these problems are just practice just to make sure that we know what these terms mean. So I think we're good with that one. How about the next x-intercept? Looks like it's about here. That one, it's kind of a stretch to say it's negative 3.3, but oh well, I think I'm just going to say that. Or sorry, negative 3.3, negative 3.5. But yeah, if you said it was negative 3.75 or something, that's probably more accurate than mine, but again, this is just a practice problem, so you don't need to be perfect with it. And I believe the last x-intercept is over here on the right side of the y-axis between 2 and 3. So I'll just say maybe about 2.5 would be that x value. Alright, I think that covers it. There are 3 places where this graph intersects the x-axis. And I believe we got them. Or at least we were pretty close to them anyway. Alright, next question. Y-intercept, or intercepts. Well, that is misleading. It sounds like there's going to be more than one, but there's actually only one. This guy right here at y equals 2, it looks like. So for x-intercepts, you only specify the x value. For y-intercepts, you only specify the y value. And it's pretty typical for these that there should only be one y-intercept, because if there was more than one y-intercept, we wouldn't be dealing with a function. We'd be dealing with, you know, just a relation that's not a function. But in real life, all applications will be modeled by functions, so it'd be kind of silly to look at an example that's not a function. But we should only have one y-intercept at any given time. Alright, I think we're doing good here. What's the next thing? Decreasing intervals. Okay, looking at this graph, if you recall, a decreasing interval is an interval on which, if you look at the graph from left to right, kind of the way we read, it would be going downward from left to right. So actually right off the bat, if I'm looking at the very left side, it starts up high and it goes low, you know, from left to right. So I'd start right there, negative infinity, to wherever it stops looking like it's going downward. And I believe that would be this low point here, right? That's when it stops going down, it's going up from there. And I believe they meant that to be at negative 5. That's about the x value. And if you recall, it's kind of confusing, but decreasing, increasing, and constant intervals, we only talk about them as open intervals. So although there is an actual point at negative 5, so you would think you would use brackets like we did in the range, it's just by definition when we talk about increasing or decreasing intervals or constant intervals, it's just automatically we only talk about open intervals. Alright, so that's our first decreasing interval, and then from negative 5, looks like from there to negative 3 it's increasing. I'm not counting that. From negative 3 to negative 1 it's constant. It's not going up, it's not going down. From negative 1 till about, what's this value here? Positive 1. It's increasing, so I'm not interested in that yet, but once it hits positive 1, I believe that's when it starts decreasing again. So from there till positive 4 would be what I would want, and I believe those are the only 2 decreasing intervals. Okay, so similarly, increasing intervals are those on which, if you're looking from left to right, the graph goes upward. So let's see, increasing would be from negative 5, kind of where we left off for that first decreasing interval, up until negative 3. Okay, and then it's constant from there, but once we hit negative 1, it starts increasing again up until positive 1. Uh-oh. Kind of ran out of room, but I think there's one more tiny little increasing interval from x equals 4 to x equals 5. Kind of where the bottom of this hill here starts going upward. Alright, I think we're good. What about constant intervals? At this point, it's kind of like what's left over. What parts of the x-axis have we not covered? Looks like from negative 3 to negative 1, I'm looking at this portion here. It's definitely constant. And I think the only other constant portion is over here on the right side, between 5 and infinity, because it goes to the right forever. And I believe between the decreasing intervals we listed, the increasing, and the constant, we've covered, you know, the entire graph, actually the entire x-axis. So that's a good sign. Alright, I think we're doing good here. What do we got next? How about local maximums? Remember we said local maximums, you just list the x values and we say, alright, maximum values are the tops of hills. So how many hills do I have here? Actually, there's only one hill right here. You might think that this is a hill, but remember that a local maximum only happens when the values on its left and its right side are below it. But this point, at -3, does not have any... It's not going downward on its right side. So actually, there's only one local maximum, and it's at x equals +1. Oh, shoot. This thing's not working very well. Well, okay. X equals +1. And that's it. Let's see. And local minimums, similarly, they are where... Not where the graph has a hill, but the opposite of a hill, where there's a valley. So it looks like there's definitely one over here at +4. There's a valley, so I'm going to say at x equals 4. Is there another bottom of a valley? Yeah, technically over here at x equals -5. That's also the bottom of a valley. Even though it's not rounded, it's squared off. All the x values to its left and to its right are higher than it, so it's a local minimum. And let's see, we're almost done. We're doing pretty good. I'm pretty happy about our progress here, you guys. Hopefully you're still with me and you're having fun. You're drawing in colors, which always makes it more fun. That's what I like to do. And alright, where are we now? This guy. So the notation, if you're comfortable with this notation, these problems here are no problem at all. So just remember, when they say f of -1, like they have here, they're saying x equals -1, and they're wanting the y value. So all I have to do is look at the x-axis, look at x where x equals -1, which is right here. Oops, I missed it, but you know, you get the idea. And they're wondering, for the graph, which point, or what is the y value for the point whose x value is -1? So I think it looks like this point right in here, kind of the right edge of this constant interval. And it looks like the y value is +1, I believe. Yeah. So I would say that's the winner. There's only one y value for which x is equal to -1. Alright, and then similarly, actually, let's jump to this one right below it before going on to this next one. Because this is a very similar question. Now they're saying x equals 5, and they're wanting y. So now I'll just look at, what about when x equals 5? That's right here. Let me line that up with the graph. I think what they mean for this point to line up with is -1, even though it looks like it might miss it a little bit. It might be a little lower. But I think that's what they're trying to convey here. So f of 5 would equal -1, and that's because the point 5, -1 is actually on the graph. And kind of similarly for this past one, -1, 1 is a point on the graph, which is why our answer was +1 when they gave us an x value of -1. Alright, last one. We made it, you guys. We made it. Hopefully you're still with me, and you haven't fallen asleep yet. Alright, this one, they're doing the opposite. They're giving us the y value. They're saying y equals -2. Because remember that f of x is another way of saying y. Just a different notation for it. So they're saying y is equal to -2. What is x? So this time, instead of looking at the x-axis and finding a certain value, I'm going to look at the y-axis and find a certain value. So let's see, at y equals -2, that's here. Sorry, I've drawn all over this thing. You could probably barely see what's going on. But I think, actually quite a few values, or quite a few points on this graph line up with this guy. Looks like there's one here on the left. When y equals -2, you got this point, this low point, at x equals, -5. That's one of them, but also I have a point here. Hopefully you can see what I'm pointing at. Right here. Oh, don't. Oh, bear with me. I'm sorry. First video. I think it looks like that point is at x equals 3. I believe. Kind of part of the way down here on this decreasing interval. And the last one I think that lines up with x, or y equals -2 is about here. And it's kind of a stretch to say that's at x equals 5. I might say that's at x equals 4 point something. 4.6? I'm getting too specific here. But anyway, hopefully you get the picture. Thanks for listening. Hope you're having a good day. See you later. Bye.